So in this video, we're going to go through how we can be looking at graphs or creating graphs and use them to analyze data and make conclusions from them. So here is a typical example of a circle graph that someone's made. We can look at it and just make some conclusions based on what we see. So it says, which sport is the most popular? So just at a quick glance, you can either look at the numbers or look at the size of each segment, and you're going to see right away that football is the most popular sport. So right away, we can see that that's going to be football. And my pen doesn't seem to be working, so I'm going to have to write with my finger. So it might be a bit messy. And then we can look again, which sport is the least popular. In this case, basketball, which makes me sad because it's my favorite sport. It's the smallest. It only has 3 people. Now, the next question, how many students are in the class? That's a little bit harder because we don't have that answer at first glance. What we have to do is we have to actually add up the numbers that we see. So we have 3, 5, 4, 6, 7. So in total, we see that that would be 25 students in the class. Whoops. I'll just erase that there. And then the last one here, again, we got to do a little bit of work. It says, which percentage of students like baseball? So we know that there are 5 students that like baseball out of 25 students in the class. Remember, to turn that into a percent, we do the numerator divided by the denominator and times it by 100. Or we can just try to think about what that would equal out of 100 and see that, oh, to go from 25 to 100, I multiplied by 4. So I need to do the same here, and I get 20. So 20% of the students like baseball. So we can look at graphs, we can look at data, we can make conclusions based on that. So right away, when I see this, I can say, okay, if I were planning something for this class, I would make sure that we planned an activity like hockey or football. We're going to get more people interested than an activity like basketball or soccer. This next graph, I'll just adjust that a little bit. Again, we can look at this. This is a line graph. And line graphs help us to see trends in data over time. So right away, what we can notice here is, what do you notice about the line? What's happening over time? So what you hopefully see is that the line is going up. It's increasing over time. So probably what's happening is the rabbit is growing. Right? The line is going up. The trend that we see is that we're increasing. The question, what was the mass of the rabbit in March? All we need to do is find March and then go across. And in March, the mass was probably about 1,400 grams. Again, I apologize for the quality of the writing. My pen has stopped working. Next question, in which month was the mass approximately 1,000? So that we have to do in this case is find 1,000 on the vertical, go across, and then go down. So a little bit different than the first one. And that looks like, oddly enough, it's somewhere between October and November, which I think I'm slightly reading this wrong, but I'm going to say October. But somewhere, probably mid-October, let's say. And then it says, what do you predict this graph will look like if you continued to track it? So that's the interesting thing about when you graph data, is you can make predictions based on what you see. So there's a couple different things you can think about here. One might be, well, the mass of the rabbit is increasing. So I might think, if I kept tracking the mass of the rabbit, it's probably going to keep increasing. Then some of you might think, wait a minute, a rabbit can't just keep increasing and keep increasing. So are there reasons why this rabbit has increased? Well, maybe it was born in September and it's growing, and now in April it's a full-grown rabbit and it's going to plateau or level off. That's a possibility. Maybe it's starting, and I actually don't know whether rabbits hibernate or not, but maybe it's growing, and because it has food and it's hibernating over the winter, now April's coming, the weather's going to get nice again, that little rabbit's going to get outside and go running around, and it's going to lose weight. So we don't really know for sure. It could keep increasing, and then at some point that poor rabbit's probably going to need to go on a diet. It could level off because maybe it was a baby rabbit, or it could decrease because maybe now spring's coming and it's going to be more active. All we can do is make a prediction based on what we see and support that prediction with reason. The good news is there isn't really a right or wrong answer. Now, some interesting things about graphs that you'll see out there in the news And actually right now we're seeing a lot of statistics out there and a lot of graphs. And I'm not saying that those are all wrong and they're all lying, but some of it is. So just like I said earlier in another video about how there's that stat out there where 3 in 4 dentists recommend Crest toothpaste, right? We don't know for sure if that's actually true. Are they paid by Crest to say that? Is it like, there's all sorts of things you have to consider when you're looking at graphs, when you're looking at data, when you're looking at statistics. So let's look at an example here. So when we look at this graph, and it is about pumpkins in the garden. So people, each of these 3 people planted a pumpkin seed, and here is a graph of the pumpkin growth. Is this a misleading graph? Why do you think so? So pause for a second if you want, think about it. So basically, whoops, the answer is yes, it is a misleading graph because we don't have a scale at all. We have no idea, is this weight, is it volume, is it width, is it height, is it how many pumpkins? We don't really know what this graph is. We can't really make conclusions. What about this one? Is it better? What are your thoughts? So again, keeps doing that. This graph is much better because we have a scale. We know that we're looking at pumpkin, and we could look and see what the weight of each pumpkin is. Probably the only thing that I would like to see is right here in this space, you know, a nice title. All right, so what about this graph? Scale has a label. Is this a good graph? So again, when we're looking at this graph, what we have to notice is, hey, wait a minute. The graph starts at 9. Graphs are supposed to start at 0. By starting this graph at 9, it looks like Mary's pumpkin weighs next to nothing. And it looks like Anne's pumpkin is huge in comparison. Now, if we go back for a second, clearly, Anne's pumpkin is bigger than Mary's. We know that. Mary's is about 10, Anne's is about 40. We know that it's bigger, but is it that much bigger? Look at the size of those bars. So again, by choosing a scale that does not start at 0, it makes it look like the pumpkin for Anne weighs way more than Mary. That's not the case. Again, what about this one? Who do you think might have made this graph? So again, this scale starts at 0, but this one goes all the way up to 150, even though our biggest pumpkin is only about 40. What it does is it makes the data compress, and it makes it look like Mary and Anne and Joe are actually not too far off from each other. Yes, Anne is still the biggest, but she's not like crazy big compared to Joe or Mary. Well, that's just because of the scale. So if I were to guess, I would guess that Mary made this graph to make it look like her pumpkin wasn't so small in comparison to the others. It's really important that you choose a scale that's appropriate for your data. Otherwise, you're going to distort the data, which, again, as I said, sometimes people will do to try to make you think something that isn't true. Here's another way. This is a pictograph, another way of displaying it. So what do you think? Is that one good or this one? Right? Which one of these two do you think is a fair graph? Well, this one, pretty good, right? Each pumpkin, 10 pounds. Anne has 4 times as many as Mary. Makes sense. This one, look at the size of Anne's pumpkin. Yes, Anne's pumpkin's bigger than Mary's, but is it that much bigger? So here, whoa, Joe's pumpkin, twice as high, twice as wide. Anne's is like 4 times as high, 4 times as wide. Is it fair? Of course not, okay? We have to be really careful. The other thing, I don't know if you noticed this, but the writing for 10 pounds is much smaller than the writing for 40 pounds. So when you are looking at graphs, when you are looking at data, when you're reading things in the newspaper, seeing things on the internet, seeing things on TV, really look at them with a critical eye and think about the motivation behind them, and think about, are there pieces that maybe have problems, and is the person who put that out there trying to influence you in a certain way?